Hello everyone, welcome to Driven Math and Physics. We continue from where we left off in the previous video, where we were calculating the distance under a velocity time graph using the area under the graph. So now we're going to try and calculate that same distance which we found here using now equations of accelerated motion. Now, to begin with, we're going to demarcate our graph into A, B, and C. Okay, so we're going to start with part A. On part A, we have to take note of something. First of all, to find distance, it will be S is equal to UT plus half AT squared. So from here, we don't know A. A is change in V over time. So for that part A, the change in velocity is final, which is 30, minus the initial, which is 0, which will just give us 30. The duration is 10 seconds. Okay, that gives us 3 meters per second squared as our acceleration in the first part of the journey. So if we substitute everything into here, initial velocity, remember, was 0, so this term will end up becoming 0. So we'll just remain with half. Where there's acceleration, we'll put 3 meters per second squared, multiplied by the time is 10 to the power 2, which will give us 100 seconds squared. So that will be half multiplied by 3 meters per second squared multiplied by 100 seconds squared. The seconds can cancel out. 2 into 100 gives us a 50. Then the answer here will end up being 150 meters. That's the first part of the journey. Okay, now when we go to the second part of the journey, you find out that S will still be equal to UT plus half AT squared. But here you will notice that there is no acceleration. This point is a point of constant velocity. Okay, so it means this acceleration part will end up becoming 0. So it will just be U times T. The initial velocity at this point, we started with 30 meters per second in this part B. The initial was 30. Okay, we multiplied by the time duration, which was 20 seconds. When we multiply the two, what we end up getting is 600 meters because the seconds do cancel. Okay, from there we'll look at part C of the journey. So S is still equal to UT plus half AT squared. Now here the acceleration on this part of the journey is deceleration. If you remember, we actually calculated it right there, okay, in the previous video. So it's negative 6 meters per second squared. So the initial velocity here was 30. So it will be 30 meters per second multiplied by the time duration, which was 5 seconds. And then we add the 2. It will be half. Acceleration is negative 6 meters per second squared multiplied by the time was 5, which will be 25 seconds squared. Okay. When you do the calculations here, it will be 150. The seconds cancel out. Meters plus. Here it will be half. 3 times 25 gives us 75, so it will be negative 75 meters. Okay, when you manipulate the two, you end up finding 75 meters. Okay, so if you're going to find total distance now, okay, total distance will be equal to 150 meters plus 600 meters plus 75 meters, which gives you 825 meters. So you end up finding the same answer as in the previous solution. So this is how you do it. Thank you so much for watching.